Hello students, so in this video I will tell you how to find the moment of inertia of a triangle. Okay, so here we have got a triangle. This is the base of the triangle with side length B, and this is the height of the triangle H. And parallel to the base I have taken an axis over here at the vertex of the triangle. So I have to find the moment of inertia about this axis. How would I do that? So first of all I will take a element on the triangle. Okay, I will take a thin strip, rectangular strip on the triangle. This is my rectangular strip. Okay, this is my rectangular strip. This distance is equal to, let's say, x. Then the thickness of the strip will be equal to dx. Let the height of the strip be equal to y. Now look at this triangle. Okay, and look at the whole triangle. Both of these triangles will be similar because this angle is equal to this angle is equal to this angle, and they have a common angle over here, so both the triangles are similar, right? So ratio of the base y divided by b should be equal to ratio of the heights x divided by h. So I get from here y equal to b by h times x, and therefore dy will be equal to b by h times dx. We have differentiated this. Okay, now we find the area of the strip. Area of the strip will be how much? So area of the strip, it's a small area, so we'll call it dA, will be equal to height y into its width dx. So it will be equal to y dx, but y is equal to b by h times x, so b by h multiplied by x, and then we have dx over here. Okay, so this is the area dA of the strip. Now what is the mass of the strip? So for the whole triangle, the total mass is assumed to, let's say it is m. So for total area of the triangle is how much? B times h by 2, that is having mass m. So what is the mass of this area dA? So area dA will have mass how much? B divided by total area, that is bh by 2 multiplied by area of the strip dA. So this is your mass dm of the strip. Okay, so dm will be equal to 2m by bh times dA is what? B by h x dx. So this is equal to 2m by h square x dx. Okay, this is the mass dm of the strip. Now about this axis, what is the moment of inertia of the strip? So this strip is parallel to the axis. So all the points on the strip are at distance x. So we can directly write down moment of inertia of the strip will be how much? Di will be dm multiplied by x square. The distance of the strip will be equal to x. So we put the values of dm over here. So di will be equal to 2m by h square, and we will get x cube dx. Now we have to integrate on both the sides. So our limits of integration will be what? The triangle is starting from x equal to 0. Okay, and ending all the way up to h. So the limits for x will be 0 to h. So you will get moment of inertia will be equal to 2m by h square. Now the integration over here will give you h power 4 by 4. So you'll get this to be equal to m h square by 2. This is the moment of inertia of the triangle about an axis through its vertex and parallel to the base. Now if you observe something, the moment of inertia is only depending on the mass of the triangle and the height of the triangle. It is not depending on the length of the base or the shape of the triangle. The angles of the triangles are not important. So whether you have an acute triangle, scalene triangle, right angle triangle or obtuse angle triangle doesn't matter. All you need to know is the height of the triangle and the mass of the triangle, and you can find the moment of inertia. This is the moment of inertia about this axis. Now if you look at the center of mass, so the center of mass of the triangles will lie somewhere over here. Okay, the center of mass of the three triangles will lie on How much distance? The distance of the center of mass from this axis, from the axis near the vertex, will be 2h by 3. Okay, because center of mass is basically centroid, and centroid is at the 2/3 of the distance. Okay, so the total height is h, so center of mass will be at how much distance? 2h by 3 from the vertices. All right, so about this axis we can find the moment of inertia very easily. So ICOM will be I minus m times 2h by 3 whole square. We are using the parallel axis theorem. So ICOM will come out to be equal to, so that will be equal to mh square divided by 18. Now we have one more axis, that is if we want to find the moment of inertia about the base of the triangle, then again it's very easy. Okay, so about this base, how do you find the moment of inertia? So the distance between these two axes will be equal to h by 3. Okay, this distance is h by 3, so again between these two axes apply parallel axis theorem. So I base will be equal to ICOM plus m times h by 3 whole square, and if you apply the values you will get this to be equal to mh square by 6. Okay, so these are the values of the moment of inertia for a triangle, whatever be the shape of the triangle. Okay,